So regression analysis looks at how two variables relate to each other. That's why we call it linear regression. So under linear regression, you need to understand which one is your dependent variable and which one is your dependent variable. So your dependent variable is your result. Your independent variable is your input. Now, there's a way in which we come up with the regression equation using the manual and the statistical way. When you're given the manual way, you could simply come up with columns like this. These columns of x, which is your dependent variable, and y, independent variable, you come up with your x squared, y squared, and xy by summing them up to get the figures you have below there. So the total under x is called summation of x, total under y is summation of y, etc. up to summation of xy. So using the manual way, we have the regression equation, which is given a plus bx plus e, where e is simply the error term. So when we compute this, our dependent variable in this case is depicted by y, and our independent is depicted by x. So using a linear regression, the formula that we use to calculate the slope is summation of xy minus summation of x times summation of y over n divided by summation of x squared minus summation of x to the power 2 over n. So this is the equation function that we use. Sometimes this n is brought in front here to simplify your work, which becomes summation n summation of xy minus summation of x times summation of y divided by n summation of x squared and summation of x to the power 2. So this is the linear way or the manual way of doing it. So when you input the values of x squared, and y squared, you're going to find your b as 3.533. Then to find your r, which is called the multiple r, you have a formula which is given below. So in this formula given below, you simply substitute the values that you have. So once you substitute the values, you're going to get your r as 0.922. So this means that you have a positive relationship between our values of x and our values of y. So meaning advertising has a positive impact on sales. Then to find your a is called the y-intercept. It is the mean of y minus b, mean of x. Or the long cut is simply summation of y over n minus b summation of x over n. Same thing. So given the values that you've been given, once you input them in there, you're going to find your a as 7.6. So this will give you the full linear regression, which is given by where there is a, put 7.6. Where there is b, you put 3.533x. So this is your linear regression. Remember, we're dealing with what? X against y. So if you're going to input this under Excel, it will give you the following output of statistics: multiple R, which is 9.22, of which we calculated here. Okay. Hello?
Yes.
So the R squared is what we just calculated. It's coefficient of determination. So this R, once you square it, to give you this figure that we got here, 0.851. There's adjusted error, the standard error, and the number of operations, which are 10. So this one can be done using Excel or Stata. So once you input everything, it comes out as simple as this. So whatever I'm just from doing is dependent on your ability to interpreting your data. So this information to you is like an FBC, a full blood count that doctors look at. They're able to tell whether you're healthy, what is happening. Now, I am giving you an economic eye to interpreting the results. Now, for you to interpret the results, you need to go to the coefficients. On the coefficient, it's stated clearly that there's an intercept and there's also the variable. And the variable has been stipulated here as advertising. At that point, are there any questions? Are you together?
The formula for R square,
Mm.
the coefficient of determination, is it provided for?
No, just square the error. Just square the
Square
error.
R.
There's no need for a
So,
formula,
and
you
then,
just square the error.
so the coefficient of correlation, that one has to be computed.
No, so I'm trying to take you from uh, the manual to the already calculated. So what I was driving you through was
Already calculated.
the manual way. Now, forget the manual now. Everything was pointing to this. So my skills that I'm trying to teach you is now how do we interpret this? So the y-intercept is called your A. Then the variable here is called your B, in short. So what is our A? From this diagram, our A is what?
7.6.
Correct. What is your B? 3 point what? 5.
3.53.
Excellent. Then you just fuse them in here. Where there is A, 7.6. Where there is B, 5.33. Which is this? Facila. So this is our regression equation. Are we clear at that point?
Yes.
Yes.
The next question you would want to ask you is simply, you may ask the same exact questions. Okay, the model, you may not ask because everything has been done in an economic model. You say, identify the dependent and independent variables. Which ones are our dependent variables? You can even tell from here. The dependent,
Dependent is Y.
yes.
Sales.
Our
Dependent.
this one, these are X values here. The intercept has down X values. So the dependent variables, the independent variables here are what? Advertising. And the dependent variable is sales. So here you can state dependent variable, advertising. Independent variable, advertising, dependent variable, the sales. The next equation from the output that you have, give a report on the coefficients, the standard errors, the test statistics in the report that we have and the R squared. So now this is a report we're giving. Number one, the BO, which is our y-intercept is 7.6. The B1 is a gradient, which is 5.3. Now, when we put it in the equation, y is equal to a plus bx. It gives us the equation. Y we know it's sales. So sales is equal to 7.6 plus 3.53 of advertising. So after that identifying, you need to interpret this one here. Number one, what does this intercept mean? It means the point at which we can make a sale without advertising. So from this equation, it means when there's no advertising, at least we are able to sell 7.6 on average. Then what does this mean? 3.53, it means that on average, when we increase our advertising expense by 1 unit, our sales will increase by 3.53 units. That's what it means. Any questions thus far?
I've got it at least.
Any questions?
Collins, the 3.53, what does it mean?
Can somebody interpret that?
It
He
means
explained
when you
that
make an advert,
Coefficient of the verb obey.
when you make an advert, you get an additional sale of 3.53.
Okay. Thank you for that. Any other question? Okay, is this more clearer now?
yeah, it is.
Okay.
This one is okay. No, the other one.
Okay, it's just that your minds were not prayed for before then. Now things are opening up, right? Yes, so we've been asked to say from the output, interpret them, then write a specified model with the values and interpret the coefficients. So we've done everything now. The other part that I wish to just mention is to see whether advertising is significant. You check the lower bound and the upper bound. You check the lower bound is 2.3, the upper bound is 4.73. So these ones, they're all positive. One is a positive and the other one is also a positive. So it means advertisement has a significant impact. All right. So this one, it means its advertising is significant. It's affecting our regression equation significantly. Then the overall equation, you need to compare this one here, the 0.00142 to the 5% or 0.05. If it's smaller than 0.05, it means it is significant, the whole regression equation. So this one is also significant, the overall equation, so which is a good thing. I repeat, when you go to the upper and the lower limit, my intervals are you also got a positive or you also got a negative, it means it is significant. If one is positive, one is negative, it means it is not significant. So upper, it is significant. Why? Because both are positive. Are we together?
Yes, yes.
Yes. Then they may also ask you to say the overall equation, is it significant or not? You check here. You compare this one to 0.05. Then you say, no, there's a problem. It's not significant. But if it's small, it is significant. So it also tallies here. You can see that the regression equation is also significant. So this is a full 20 mark question. And you're home and dry. Any questions?
So it's less than 0.05.
Mhm.
How now the question would be rejection of the present value. How do you interpret that one?
Do you mean rejection of the present value? Don't complicate it so much by stating the null hypothesis. Just get what I've said to say if it's smaller than 0.05, just say that the regression equation is significant. It's statistically significant. Upon at 0.1000, that number could have been bigger than 5% or 0.05, which is 5%. So it means that, in short, just multiply this by 100. We're getting 0.0014. If it's less than 5%, you're converting it percentage, just know that it is significant. If the p-value is less than 5%, that know the regression equation is significant. I rest my case. Can I proceed to something else? Okay. Assignment question number 1. We were given the total revenue and the total cost. So we're asked to find number 1, the units that will maximize your profit. Number 2, the actual profit. So you go, profit is equal to total revenue minus total cost. When you're putting the negative, put brackets there so that you follow them through properly. What is negative becomes positive. What is positive becomes negative. So this negative, the 8.5 becomes positive. The rest are negative. So when you rearrange this thing, you're going to get your profit function to be like this. Then, whenever you're asked to maximize any equation, they are simply asking you to what? To differentiate and equate to 0. To differentiate and equate to 0. So, marginal profit over quantity. So when you multiply negative 28q, we get 28. 8q squared, we get 16q. 1 over 3q cubed, multiply this, the 3 cancels, we remain with the 2. What happens to the 90? It drops out. So this is what we call our marginal profit. So using our quadratic equation, we identify our A. What is our A here? -1. Our B, positive 16. Our C, negative what? 28. Then you fuse this in the quadratic equation. Preferably, you can rearrange them in the order that we know, that ax squared plus bx plus c. The a is the coefficient of the x squared. So our a there is what? -1. Our b is positive 16 and our c is negative 28. So this is a general formula that we use whenever we're calculating the values. So this is a quadratic. Quadratic means you are going to get 2 values of q. So when you input here, we're going to have what? When we input here, we're going to have our q as negative 16. All right. Then b squared, 16 squared minus 4ac. Our a is what? -1. Then we have negative 28 over 2a. And when you put in here, we're going to compute all this and calculate our value. So we're going to get plus minus 12. And then on 44, you need to take your time to calculating the values of q. So you're going to get 2 values. One value of q will be 2, and the other value of q will be 14. Usually the big one is the one that will maximize, but don't guess. There's a test that we use. Number 1, how do we test which of these 2 qualifies? If one was negative and one was positive, definitely we pick the what? The positive one, because quantity does not need to be a negative. Are we together? Then secondly, Morasha Ishwa differentiation, you can use the grade 1 way. Use this to mkatumuli profit function. Yala kupera bigger figure ya kusenda. When you try 14, it will give you 171.33. When you try 2, it will give you a loss of negative 116.67. So which one of the 2 will you pick? You pick the 14. But if you're an economist and pass through my class, you will not do that guesswork. Of course, you're going to differentiate this again for the second time. Profit differentiated for the second time. So when you differentiate this, this is a 0, and we're going to get 16 here. And differentiate, and here we're going to get minus 2q. So since we have found 2 values, there's a 2 and there's a 14. When you put a 2 there, it will give you positive 12. When you put a 14 there, it will give you a negative 12. So according to the maxima rule, you get the quantity that will produce a negative value of the second derivative. So we pick 14 here without guessing, because that is what the rule says. So we find 14. So 14 is then the quantity or the output that will maximize your what? Your revenue. Not your revenue, your profit. All right. So going down there, after you find that, they'll ask you now, therefore, find your maximum level of output, your maximum level of profit. So using the 14 that we found, let's go into this equation here. We substitute the 14, of which we already did get our 171.33. So this is how we were able to identify. Okay. This is
Collins, that if to differentiate for the second time, which function do you use?
the marginal profit, this very one, which we did
Okay.
here, the marginal profit function.
Excuse me, Mr. Collins.
Yes, sir.
So we are learning quantitative and the ME at the same time.
Exactly. We're learning quantitative and ME at the same time.
Oh, okay. Nachifokuru nachimona anova first kule.
It's the same because these two courses prepare you ultimately for research. Okay. Okay, now let's go to our MBA paper again, because this is a style of what? This is a paper that he prepared. See where the assignment came from? This one is the exact assignment. And you see the allocation, there's 8 marks and 4 marks there. Okay. So Mwaliako 4 marks, please don't make mistakes. This one, guys, a terrible exactness. Remember, answer nishan 14. Kule mbele pambari, ero mambo solving, 14, then imbinchan ni 2. Okay. So then this one is production, production. So before I go to that one, I want to look at something easier. Okay. This one here. Which one do you want me to look at? Question number 6? Were you able to balance up question number 6? So question number 6, we're given the demand function of a firm.
Number 6 is straightforward. We looked at it.
We managed to crack it down.
Yeah.
Okay. So can I proceed something else? Mwase, are you comfortable with question 6?
My total revenue, my maximization profit.
Okay. So can we look at question number, this one here?
Yes. I'm okay.
Okay. Get your pens. You write the total cost function here. This is under cost theory. Okay. So find the number of passengers per day that minimizes the average cost. So to minimize, we find what? The total costs, differentiate it and equate to 0. Find the number of passengers per day that minimize the average cost. What are we minimizing? Average cost. So what are we given? Give me the figure. Have you written it down? Tell me the total cost. Total cost is got what?
100p.
What?
100p
Uh-huh.
minus 64p squared plus 4p to the power 3. That's all.
So the question is, minimize what?
Average cost.
Good, average cost. So what mistake would everyone do? They'll quickly go to differentiate this and you get to 0. but that is minimizing the total cost. First, we need to find, step one, find the function. How do we find average cost? Total cost divided by what? Quantity. All right. So our average cost therefore will be what? Our quantity is P because the number of passengers. So total cost here divided, the P is not price per part. It's a quantity in this case. We are dealing with passengers. So average cost here will be what? 100 minus what? 64P plus what? Plus 4P squared. Are we together? Step one, find the functions. Step two, remember step two? Differentiate.
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 So our AC, when you differentiate once, we're going to get what? Negative 64 plus what? 8P. Step three. Step three,
Equate to 0.
get to 0. So we have negative 64 plus 8P. So when this one goes the other side, what do we have? 64 is equal to 8P. So we divide both sides by 8. What do we get? Divided by 8, divided by 8. The number of passengers that to minimize cost is what? 8 passengers. Are we together? And people perished because of what? Lack of knowledge. So find the number of passengers per day that minimizes average costs. So the second one, find the bus fare. Yes.
So you just, on equating to 0, you just divided the 8P to find the P.
Mhm.
You divided 8 both sides, isn't it?
Yes.
Okay.
Any other questions? Any other questions? Are we all together?
Number, do we have negative quantity?
No, but did we get a negative? We don't have negative quantity.
Maybe I copied wrongly because I have a negative 68 here.
No, negative 64, because you've equated to 0, it crosses the equal sign and goes on the other side. So you have 64 is equals to
Oh,
8P.
okay. Thank you.
Okay. Any other?
Mr. Collins, just on the, I want to see how we've dealt with 4P to the power 3. Okay, so 3 minus 2, okay, it becomes 2. Now the one at 64. Just on the one at 64, I think.
Mhm.
Yeah, just the one on the 64. I followed through the 100 times 1, then p minus p to the power 1 minus 1. We remain with 100. The second one on 64p. So we've also multiplied 64 times 1, not 64 times 2.
Um,
When finding the average cost on step 1.
Step 1 average cost, we divide the total cost divided by p. So 100 becomes what? The p cancels out. So it's the 4p squared, 1p comes out. Then here when divide by p, there are 3 p's, we're going to remain with 2 p's. So dividing by p throughout.
Or dividing by p, okay.
Throughout. Then that's when we differentiate. It was a tricky question. It required good analysis. Okay. Any other questions? Okay, so we can go to another question now.
What about part B?
Okay,
Part 2.
part 2, find the bus fare that for TBS to break even. How do we break even?
Fixed cost divided by selling price minus the variable cost.
You twice the account.
Fixed cost divided by selling price minus there's a function that is missing here that needs to be there. I think I can't see it. So break even occurs where our price or total revenue is equal to total cost. So we break even, or where the profit is equal to 0. So there's an equation that is supposed to be there, but I'm not seeing. Okay, so we can go to the other paper. This one here.
So this one is under production.
Yes, that one is under no, under cost theory.
Cost theory.
Yes, under cost theory. Okay, so what topic did we do that remained for the production, for the schedules? So let me look at the question for the schedules. Production schedules. M and E Also, I'm looking for those questions. Any topics that you feel you're behind?
I have a question, not really that I feel behind, but when we're given the price function, and then to find the marginal revenue one, you said we multiply the coefficient of Q by 2, right?
Yes, yes.
Was there a reason why we're doing that?
Okay, I'll explain. When you're given a price function, P is equal to 1000 minus 4Q. And you're asked to maximize revenue. So how do you maximize revenue? Step 1, find the revenue function. So what is our total revenue? Price times what? Quantity. So our price is 1000. Our Q is here. So when you multiply this by that, we get 1000 Q minus what? 4Q squared. That's step 1, find the total revenue function. Step 2, you differentiate. So our MR is equal to 1000 minus what? 8Q. So because economists realize that most of you don't want calculus, these two, just multiply with that 4 to avoid this step, just to get your MR. You simplified your life. It is always the case that for a linear function that you're given, to get from price to MR, just multiply it 2 there. That's what will give you 8.
Oh, yeah. Okay, that makes sense.
So step 2, differentiate. Step 3,
Follow-up question. Oh,
equate to
sorry,
0.
finish. Sorry.
So when you get to 0, then when this one comes aside, you divide by 8 on both sides. Divide by 8, we're going to get 125 as the quantity. Then to find the price, you replace this in the price function. So where there is 8, where there is a Q, we put 125. So when you multiply this by that, minus 1000, you get 500. So the B is -4. The B is your gradient here, -4. So to calculate the elasticity of demand, the formula is simply, once P is subject formula, we use the inverse demand, 1 over B times price over quantity. So our B is what? -4. Our price is what? Calculated the P to be 500. And our Q, 125. Whenever we're asked to maximize revenue, the answer is always -1. The elasticity of demand to maximize revenue is -1. However, if our quantity is given by 1200 minus 5P, and they ask you to find elasticity of demand when Q and P is 100. So the formula for elasticity of demand is simply slightly different. It's simply B times price over quantity. because this is a direct demand. If it was P there, it would be 1 over B. So the first thing is substitute the 100 in there. So it will be 1,200 minus what? 500 to get what? 700. Then you substitute the figures in there where there's B. The B is simply the slope, the number that comes for the lead. So -5. And our price is 100 and the quantity is 700. So when you divide that, you get -500 divided by 700, which gives us what? 0.7 negative. 0.712, somewhere there. So whenever your elasticity starts with a negative, we call that inelastic demand. So demand can also come in schedules to say the price of bread rose from 5,000 to 6,000. This caused an increase in your demand to go from 500 to, whenever price increases, what will happen to demand? Demand will decrease. Cause your demand to decrease from 500 to 400. So this is what we call arc price or midpoint elasticity. So elasticity of demand is simply change in quantity over Q over change in price divided by the original price. The change is simply the difference between the second and the first over the first. Don't forget that these suffixes must be the same. Don't put a 2 there and a 1. Similarly, P2 minus P1 over what? P1. So here, our P2, don't swap them. You swap them, you're messed up. Start with the quantities. So the original quantity, this was 2, sorry. 400 minus what? 500 divided by 500. Then here, 600 minus 5,000 divided by 5,000. Elasticity of demand is always negative. So when you get here, we're going to get negative 0.2. You get there, 6,000. We're going to get positive 0.2. So this will give you a negative 1. So this means demand is what? Unit elastic. So demand can also come in a multilinear equation where you're given 10 minus 2px minus 3py minus 5m plus 10a. And you'll be given the price of x, maybe it's 1/4. Price of y, maybe 2/4. Price of m, or the income itself, maybe 3/4. And your a, maybe 10/4. So the first thing you need to find the quantity or output by substituting the figures there. So where there's price of x, you put the 1. Where there's price of y, you put the 2. Where there's an income, you put the 3. And where we have our advertising, you put the 10. In this case, you evaluate. Sometimes they ask you find the daily sales. So we're going to have 10 minus 2 minus 6 minus 15 and plus what? This is 10, 100. So what this means is we have 10 minus 2, 8. 8 minus 6, 4. 4 minus 15, we get negative.
No, 8 minus 6 is 2.
Pardon? What's the final
10
answer?
minus, 10 minus 2 is 8. Then 8 minus 6 is 2. You said 8 minus 6.
Oh, yeah. Okay. Then 2 minus 15 is minus 13. So minus 13 plus 100. What is the final answer?
87.
87. So before I go into computations, I've learned about nice tricks today to say if you have a negative there and a negative there, just know that these are complementary goods. If you have a negative on the income, just know that this is an inferior good. So if we have a negative here and a positive, those are complementary.
Subs-
They are substitute.
uh,
Yes.
Substitute.
If you have a positive there, it's a normal good. So we calculate the partial derivatives, x against x. This is called on price elasticity. So what we do there is -2, which is a gradient. You just pick the gradients throughout. We have 3 gradients. We have -2, -3, +5. So this is a gradient for what? On price elasticity. It's a gradient for cross price elasticity. The gradient for the income. It's a gradient for the advertising. So 2 times the price of good X is 1 over 87. The answer we're going to get is -0 point something. So this is obviously
Negative 0.02.
0.02. So this is what?
02.
Elastic. Then when we go to XY, we're jumping from good X to good Y. The gradient here is -3. The price of good X is 2 over 87. The answer is negative 0 point what?
Negative 0.07.
So since the sign is negative, we simply say that our demand here is what? Our kind of goods are what? These are called complementary goods. These are called complementary goods. Are we together so far?
Mr. Collins,
Yes, I can hear you.
hello. M is for income, A is for advertising, Y is for what? Hello?
That's the price of what?
PY is the price of what?
Price of good Y.
Yes, M is a income.
Oh,
Yeah.
Mr. Collins, I wanted to find out which formula did you use for the -2 times 1 over 87?
The -2 is simply the gradient for good Y. -3. Okay, here for -2 is a gradient for the good X. -2, then 1 is the price of good X itself, the price for good X. Then over the 87 we got here. Then here,
Oh, okay.
-3, then the price here is what? 2 over 87. Since we're getting a negative, we say these are complementary goods. Then finally, the elasticity of income, we're going to have what? The gradient there, which is -5. Then the income itself was 3 over 87, the answer we're going to get is a negative 0 point something. So this is an inferior good. Okay. So are we together on the multilinear?
Mr. Collins,
Yes, sir.
you said when it's -1, that's unit elastic.
Yes, sir.
Okay.
And finally, we go to the market structures. We have 3 market structures that are going to be particularly important. We have what we call the perfectly competitive market, which has a horizontal price, which is your demand. So we also have a monopolistic market structure where our average revenue is twice as much as the marginal revenue. So the price MR, this is MC, then average total cost. So where marginal cost meets our marginal revenue, this is where the abnormal profit starts. Then our
Sorry, Collins, how are they identified?
so they identified, here we have drawn them. We start with the marginal average revenue, half of it marginal revenue.
Which market is this one, Mr. Collins?
It's a perfect competition. And this is monopoly. And this is monopolist. All right. Then average revenue, marginal revenue, average total cost, marginal cost. Okay. So
Collins, is there a clue for these graphs?
A question as well.
these graphs are the
You say when it curves like this, it will be this. When it curves this way, the one on the top, something like that.
yes,
Ah.
the trick is just this. Look, I was trying to explain to say, when you draw this, our average revenue is this one. And half of this is a marginal revenue. Are we together with this?
Yes.
Then you just draw a curve. This is called your average total cost. Are we together? Then
Okay.
you do half of this, Ichonged way. That is your what?
Perhaps you can start saying it on it for real.
That's all. Then we know that when MR meets MC, you look at the point where they're intersecting. MR meets MC, where are they meeting? Here. You put your dot there. Then you draw your line up and you draw a line downwards. Where the average total cost is, you join this side. And where it meets there, you join that side. So this is where your profit is, your abnormal profit is.
The pink Hannah in the pantry. Can I take it?
Oh, perfect.
The pink Hannah in the pantry.
We don't have the variable cost.
I don't have to.
No. Just these ones. Average total cost and the marginal cost also.
That's for perfect mark, perfect
No, this is for
comparison.
monopoly. Monopoly. It makes abnormal profit. For perfect market is the easiest. You just draw out a straight line there. Your price is the same as what? Your average revenue. That's all. This is your marginal revenue. It's the same as the marginal revenue. Then if you want, you can add those two curves, a cap and Ichongedo. That's all. This is your average total cost, and this is your marginal cost.
Mr. Collins, can you bring a question asking us to draw the graphs?
If they ask you to, with the aid of a diagram, describe the market structures, perfect competition, usually you ask you, describe, distinguish, compare, and contrast perfect competition and monopoly. You just draw the characteristics and draw these two graphs. Come on. But if you are not confident, leave out the graphs and just draw the two and put the characteristics. We know the characteristics, right? Okay, so any questions?
I wanted to find out, have you done a question concerning calculus?
Yes, we've done calculus already.
Oh, okay. Okay, I came in late. I'll look at the.
Okay. So thank you so much for your time.